Hey class, today we're going to be talking about scatter plots. But before we go into our examples, we got to get some definitions that are very important. And our first definition that we have is called an outlier. The outlier is the point or points that are the furthest from the rest of the other points. Okay, so it'll be kind of sitting off by itself. Okay, the next one is increasing slash positive trends. Increasing slash positive trends is when the variables move together. As x increases, the y will also increase. Decreasing slash negative trends is when the variables move in opposite direction. Whereas x is increasing, you will see that your y values will be decreasing. No trend. A no trend is when the variable moves randomly, not together or in opposite directions. Okay, so you won't be able to see a pattern in those no trends. Linear trends. Linear trends are when a straight line can be drawn through the data. And with linear trends, you have your opposite. You're going to have a non-linear trend. It's when a straight line can't be drawn through the data. Okay? Now, one important thing is that the vocabulary word trend is the same as the vocabulary word as correlation. Now, depending on the type of problems that we come across, some would say trends, some would say correlations. So it's the same thing, it's just depending on the type of problem that is presented to us. Now that we've seen a few very important definitions, let's move on to a few examples to get an understanding of how these definitions will work. Okay, so let's look at our first set of examples, and we're going to be stating whether the scatter plots that we have are going to be increasing, decreasing, or it shows no trend at all. Okay, and we're going to detail whether it's linear or non-linear. So looking at my very first example that I have here, what we're going to do is when it comes to a scatter plot and we have to tell the type of correlation or trend that it has, we're going to be looking at it as being like one section of a coordinate plane. Meaning we have one side that represents x, the other one is going to be y, and we know that our y values go up and down, and then our x values go left to right. Okay, and then those points come together and they form our origin. So when we notice that, what we're going to do is we're going to take and we're going to draw lines on the outside of our data. And when we draw those lines on the outside of our data, we're going to see the direction that these actual points are going. So like in this first example, we notice that the points from the left side of my graph going to my right, they're increasing. So that shows that both values actually are going up. My y values are going up and my x values are also going up. So what we have here is going to be a positive trend, okay? So we have a positive trend because both values are increasing. Now, by us having a positive trend, we need to determine whether it's linear or non-linear. Now, because we have the line going down the middle and it's following the direction of that line, this is a linear trend also. Okay? So it's a linear positive trend. Now, if we go to the next example that we have here, okay? Just looking at the purple line, the pink line that we have, it's already following a linear trend, so we can go ahead and label linear because of that line. Now, not all graphs will already have the line drawn, so you have to draw a line down the middle of it yourself to determine whether it's linear. But now when we follow this one, we do have our x value like we had before and our y value. Okay, we know that our y values are vertical, they go up and down, and our x values are horizontal, and those two axis lines will connect to make our origin. Now looking from our origin, or the furthest point on our left, okay, when we look here, what happens is we notice that it didn't start low this time, it's kind of way up at the top. So when we draw lines to follow that trend of the pattern, we notice that we go down. Okay, so that means because we're starting high, ending low, what it shows is that my x values are increasing. You see it from here, x values are increasing, but my y values are showing that it's going down. So that means they're doing opposite things. Okay, because they're doing opposite things, what we have is a negative or decreasing. Okay, trend. Okay, so remember, when we have to determine whether the trend is or correlation is positive, negative, or none at all, what we have to do is we'll follow the actual trend of the data, whether we can tell if it's going up or down. And sometimes we'll have some where we can't really tell at all. But let's look at our third example in this one. Okay, so if we take and look at this, we see the line that they drew for us in the middle, it turns. So this will be considered a nonlinear trend. Now let's determine whether we have it's increasing, decreasing, or it's no trend at all. Now if we follow the outline of the data that they gave us, okay, so we'll follow it. We'll notice that from the left going to my right, it was going up. So it dropped and then it came right back up again. So because it dropped and came right back up, what we'll notice is this is going to be considered to be a positive trend, okay, or increasing. Okay, so for example 3, what we have is a nonlinear positive trend. Okay, now the last example that we have, when we look at this one, we can't draw a straight line through this one because it doesn't follow any data points. These data points are kind of like all over the place. Because it's all over the place, we can't really classify this one as linear or nonlinear, okay? Because it has no trend. Alright, so since it doesn't follow a straight line, it doesn't have a linear or nonlinear trend. And because we cannot really trace the outline of this one will be a no trend at all. Okay, so this one has no trend because we can't really tell what is it doing. It's doing opposite things. So because it's doing opposite things all over the place, it's random. That means we have no trend at all. Okay, so looking at these 4 examples, we have a positive showing that it's increasing. We have a negative showing that it's decreasing. We got a nonlinear positive. It's not straight, it's not a straight line, but it still can be a positive trend. And then in our last one, we showed that this is a no trend at all. It's like the data points are all over the place. Okay, so as we move forward, I want you to take a second, pause the video, complete these 6 examples. I want you to tell me whether it's increasing, decreasing, and no or no trend at all. And then also tell me if it's linear or non-linear. Now that you completed your examples, let's see if we got them right. Okay, so look. So that's this set of examples about determining whether you have a positive, negative, or no correlation at all, whether it can be increasing, decreasing, or no trend, and if it's linear or non-linear. In the next part of the notes, we're going to be still covering scatter plots, but we've got a few more definitions that are still important. And it's talking about associations. And an association is a relationship between the 2 variables. Now, we have strong associations, weak associations, and a no association. The first one we're going to cover is a strong. Okay, the strong association is if the data points are real close together. So if they're close together, the closer they are, the stronger they are. Okay, the next one we have is a weak. A weak association is if the data points are widely spread, not close together, with some spacing. Okay, that's considered to be a weak association. The next one we have is going to be a no. The no association is if the data points are random. They're very spread out. You can't really tell what they're doing. Okay? So now that we covered this part here of scatter plots, let's look at some examples to get an understanding of it. Okay, so let's look at this set of examples. We're going to take these examples and we're going to classify them whether they're going to be strong, weak, or they have no association at all. Now remember, for it to be strong, they have to be close together. Weak, they're kind of spread out somewhat. and a no is that they random. You can't really tell it all. Okay? So looking at our first example that we have here, we're going to state the association. These points and this one here, if we look, they're kind of close together. So because they're kind of close together, we're going to make this one a strong association. Looking at our next one, points are kind of spread out. There's some spacing that's happening. So we're going to categorize this one as a weak. The next one, looking at this one, points are real close together. So I would say this will be a strong. Alright, so my next example here, points are kind of got some spacing in it. Not really that close together, so we will say this one will be a weak. Going to my next one. Here, all these points are real close together. That will be a strong association. And my last one that we have on this part, these points are all over the place. There's really no way to tell, so this is considered to be a no association. Alright, so in this next set of examples, we're going to be looking at some statements. Now, we're still going to be categorizing whether they're strong, weak, or no association at all. But when we read statements with scatter plots, we're determining whether if the statement makes sense and it's always true, then it's going to be strong. Okay? Now, it will be weak if the variables sometimes relate and the statement can be true and it can be false. Like, that means it works sometimes, but sometimes it don't. And then it's going to be a no association when the variables have no relationship to one another. Okay, the statements make no sense. Okay, so let's look at our first example. The first one says that the hours a person studies and their grade on the exam. The more you study, the better your grade. So therefore, that is going to be a strong relationship because you can tie those two together. Because if I study more, I'm guaranteed to make somewhat of a better grade. Okay, the next one, a person's height and a person's shoe size. Okay, because you don't have to be tall to have a big foot. Okay, or you don't have to be short to have a small foot. Okay, so that one there, I would say that one's weak because you can be tall and have a small foot, or you can be short and have a big foot. So this one here kind of, it's like it works sometimes. Okay, in the last statement it says the number of letters in a person's name and a person's IQ. The number of letters in your name have no relationship to how smart you are. Okay, so because of that, this will be a no association. Okay, so if you look at these three examples and you read them, you see that the first one made sense because if I study, I get good grades. The next one, you see it kind of makes sense. What I mean by it kind of makes sense is that a person's height and shoe size, they do correlate sometimes, but sometimes they don't. Okay, so that's why we say that one's weak. And the next one, your number of letters in your name has no relationship to how smart you are. So that's why that one's considered to be a no. So now that we've been through this set of examples, we're going to move on. I want you to pause your screen, complete these three examples, and then we're going to check them. Now that you completed these three examples, let's identify these three. Okay? So alright, so pause your screen, complete these three examples, and we'll go over. This is the end of this set of notes, and we went over scatter plots. So we have a good understanding of what it takes in order to identify the correlation and the association of a scatter plot. If it's a correlation, it's going to be a positive or negative or no trend at all. For the association, we have a strong, weak, or there's no association. Okay? Using what we just learned, I want you to apply that to your assignment. And if you have any questions, please do not hesitate to ask.